Hello everyone, and welcome back to Having Fun Repairs. What I've got before me is a Westinghouse computer monitor. For those of you interested, the model number I believe is right here on the back. It is a L2210 November whiskey. This monitor was given to me by a friend who says that power LED no longer illuminates when plugged in. Monitor won't turn on. I've had it unplugged in the house. One thing I'm going to do since it's unplugged is try to attempt a simple reset by holding in this power button for 30 seconds and then plugging it into the wall. Let's see, how can I do this while balancing the camera a bit? Hopefully that works. So I'm going to hold this in and plug it into the wall to see if you might not be able to tell, but there is a little red LED right here, or it should be. I guess it would go red or yellow or green or something. But I'm going to hold these in and plug it into the wall to see if it makes any difference. And we still have nothing. But I am hearing something. Okay. So with it plugged in, I'm hearing a little bit of a high frequency noise. Probably refer to it as a high pitched whining sound. Soon potentially power supply issue. Noise could be coming from inductors or coils. Not too sure. But at this point I think it's safe to say that the next step is to take it over to my bench and take it apart, see if we can start troubleshooting it. Alright, so I decided to take it apart off camera. Essentially you have 3 screws at the bottom. Then I'd use a pry tool to separate out the back clamshell from the front half. Also be careful, you've got a ribbon cable here that's going to plug into this daughter board over here, housing the controls for your side button and the little microprocessor that makes the interpretation of tactile press to what needs to be signaled into the power supply for everything to turn on. I believe those 3 lines are going to be ground lines. Try to do this one-handed. They are, and we're going to have several across this cable as well. Now I'm not positive of these. I'm pretty sure some of these will be ground line. Not sure all of them should be because I don't know what's going on with the power supply. These top 3 ones definitely are. So what I'm going to do right now is determine which ones do not present a tone with a continuity check. I'm going to hook the power cord back in to see if I can't trigger this thing to turn on from this ribbon cable right here. Alright, before I went and started shorting out pins and going all crazy on this thing, I decided that I'd go ahead and do my best to pin out that ribbon cable right there, 32-D021863. First 3 pins were ground. I took resistive measurements with the power plug pulled out of it, as well as voltage measurements with the AC cord plug back in. Pin 4, I got 54 k ohms of resistance. Pin 5, 112. Pin 6, 58 kilo ohms. And pin 7, 112 kilo ohms. I am going to assume that this is pretty normal because we see a repeated pattern here. 54, 12, 58, 12. They're all relatively in the same ranges. Probably data lines. Not too sure, but that's my best guess. Followed by ground. And then pin 9, 3.2 volts DC, 4.2 kilo ohms of resistance. Pin 10, same thing, 3.2 volts DC, 4.2 kilo ohms of resistance. And then here's where things get a little bit weird. Pin 11, I've got 2.37 volts DC and 3.5 kilo ohms of resistance. This leads me to believe as of right now that this might potentially be an issue. This voltage here feeding to the little terminal board, daughter board on the side of the back clamshell for powering things on. Not sure if that is a part of that DC voltage that needs to be sensed through that circuitry, but you have a lower DC value and a lower resistive value. Let's see, what else do we have? Ground, and then pin 13 was 1 kilo ohm of resistance, and then 3.2 volts DC. Again, the voltage here is correct. That resistive value is a lot lower. 14 is ground, and then pin 15, the best I can determine right now is that it is not connected or open. Again, that could be a potential issue as well, because I haven't traced it out to the other side of the ribbon cable to see what it goes to. But again, that could be just otherwise not connected, or not going to anything. My main two concerns are pins 13, pin 11, primarily pin 11, what we see there. Now, I could be wrong, this is a big stab in the dark. I have not yet been able to find a data sheet for this specific model LCD panel. I did pull the model number. It is Chimei, C-H-I-M-E-I, Optoelectronics Corp. A2210Z5, Z5 for those of you in the UK. But I couldn't really pull much data, any data really on this at all. So instead of just arbitrarily going and saying shorten that 2.3 to ground to see if it turns on the TV, or that pin, what is that? Pin 13 to ground to see if it turns on, not TV, sorry, monitor. I am now going to, this primarily looks like it's taped on. I'm not seeing any screws. You got a little bit of EMI shielding around this power supply with this this shell over it and this foiled tape. I'm going to try to remove this back plate here and poke around the board a bit. Alright, so here we have that unit removed from numbers, in case you need one of those. Removed from the back of the LCD panel. Be very careful, you'll have to disconnect both of these ribbon cables. They have a little tab you pull up and then you can slide them out. Just take note of that, and make sure you take note of how these cables here are connected for removal as well. So, what do we got going on here? I suspect I will be needing to further disassemble this. So I wasn't able to pull up too much on this apart from the part number and it being associated with the driver board for this LCD panel. No schematics, no diagrams from what I could find.
with a very cursory search online. I'm not going to spend hours just trying to dig it up, because more than likely I won't find anything at all. That's the nature of these types of repairs when it comes to electronics. It's not like working on a vehicle or anything where you have the right to repair. You might not find anything. So, and that's also why it's hard to attempt to reverse engineer a lot of things, because a lot of people just keep their diagrams and everything in-house, not out in the public. Anyways, off of that, I suspect, well, if this is the control board, we were getting voltages from it. Things still weren't turning on. Remember, we didn't even have an LED light, so the issue could come from here, but I don't find that likely. I think it's more going to be an issue with the power supply. We can also see that areas of this board, if I turn off the light for a second, you might be able to tell easier. You have darker areas here and here. It's a bit darker up in this corner, indicating to me that there's been quite a bit of heat. But what I'm going to do for now is further disassemble this.
Okay, we've got this guy completely disassembled now. I'm going to plug up power at some point, so I'll make sure to take off my rings, because we do have a high voltage side and we do have live power coming into here. I don't have schematics to go off of. Power board does look a little bit tired, if I'm being honest, especially around the transformers. You can see some darkening, and right off the bat I see a bulging cap here. So you have AC coming in a full wave bridge rectifier. Check those diodes real quick. The multimeter. That's fine. Close this way. That's fine. Closed, or open, sorry. Fine. And that should be open. Alright. What else do we have on this board? Well, we got a MOSFET sitting here. It's going to be hard to show that on the camera. I'll read off the part number on it, P6NK60ZFP. I think that's a MOSFET rated for 600 volts. Another transformer here. Kind of looks like an optocoupler. I probably need to look that up. Transistors. And then you got two rectifiers here. We're developing two more voltages. You have a MB-RF 10200CT. So that one's going to be rated for 200 volts. And then we have an STPS 10, I think that's a 10L 60CFP. So that one's going to be rated for at least 60 volts. And a couple inductors.
few more caps. Another transformer leading to these right here would go to the CCFL, I think is what they're called. Sorry, excuse me. What am I thinking of? The lamps. That's what I'm trying to recall. But anyways, that's providing the backlight. These pins plug into this board here. It looks like we have these two on this side. It's not connected. Yeah, they're not even. I don't think they're connected at all. So let's verify over here. Top two pins. Yeah, they're going nowhere. But then you have top two middle, ground, from down one from the top, that's the ground, and then these remaining three, bottom two on the bottom, bottom one on the top. Those are all 5 volts. That's something we can check. We'll do it at the pins. We could also do it at the rectifiers. Probably going. I'm assuming this one right here is developing that. I'll need to verify. Yeah. And then on the back, you have an assortment of SMD mounted devices, transistors, diodes, resistors, a couple ICs. I've seen 2 fuses. That's something we can check. Fuse 101, 4 amp, 24 volt. That is good. And I know I've got my camera on, it's creating a glare, but it's nighttime now and I don't have a desk lamp, so I do apologize. But for those of you who want to see, this was the fuse I just checked. And the other fuse, where did I see? Right here. It's marked F200. It's like a 3 ohm resistor sitting in there. That is good. Could be wrong what that 3 represents, but assume, make an assumption. Some more ICs. Alright, so it's pretty simple. Again, like I said, things we can look at on there. Then of course the 5 volts ground is supplied through there, comes into this board. It's like it's supplying power. I don't know what's underneath the TS'ing, but I assume that's the main processor, taking all your video signals and outputting them to your display. Probably horizontal and vertical sync. You're probably more than likely an RGB signal as well. I mean, you got DVI and VGA, so probably a duh. Some caps, a diode. What is this guy right here? APA 2068. So that is going to be some kind of audio IC, probably for driving volume control, your left and right 4 ohm speaker that is in the monitor.
through this connector here. Keep in mind this goes to those capacitive buttons, that little daughter board that's on the side of the monitor internally. So you're also receiving signals, probably find their way back to here for controlling turning on and turning off. If it's the IC that is the issue at all, probably game over. Be better off finding a broken monitor and swapping a board out than potentially finding this IC. If there's anybody who's taken the heatsink off and look this up online, you tell me in the old comments down below. Of course, your lamps can get replaced. I don't have a lamp tester, so I don't have. The only way for me to test them is if there is no fault with the power supply board. Unplug one. If I can get this to work, or say this is working, which I highly suspect it is not. There's got to be something wrong. I mean, we already have a bulging cap. But anyways, I'm going to replace the caps on here if I'm being honest. Just by looking at that. I'm going to recap the board. I'll at least recap 1, 2, 3, 4, 5. These 6. I'm not going to mess with that guy. Yeah, I think that's how I'm going to move forward. But I do want to check some voltages, so bear with me a second. I'm going to plug this in. Now, I am comfortable applying AC in here and messing with this board. But if you've never worked on power supplies before, I would recommend that you take extreme precautions before doing so. Because you do have a high voltage side, because you have live voltage, regardless, because you have caps, I guarantee you, if you lay your hands on any of these rails, you bridge a cap, you are not going to have a fun time. So when I handle this afterwards, I'm either going to one hand turn by holding the very edges of the board itself, or maybe just using the cord once it's plugged in. I'm going to take some measurements. So let me do that next. Okay, so I don't have it plugged in just yet. Because this is an ESD mat, I do not want to accidentally, you know, an ESD mat is there to discharge static electricity through a 1 megohm, might be a little bit higher, I can't really remember. But either way, I don't want to run the risk of laying this down on the mat and shortening anything out, so I'm going to put it on 2 index cards. Then let's plug it in and cross our fingers. Alright, it is plugged in now. I can hear that whine that I was hearing before. Okay. So see, was the top pin was 5 volts.
Ground not good enough? What's going on here? I wonder if I don't have this plug seated all the way in. Yeah, that's exactly what's going on. Let me unplug it, push that all the way back, push it in. Come on. Push the plug in further. Pretty silly and very stupid mistake. And let's see if we are developing that 5 volts again. Still not seeing it. Oh, there we go. Guess that was not provided. Okay. Yeah, 5.1 volt, 5.1 volt, 5.1 volt. Okay. Okay, I think it's AC that might drive. Yeah, look at that. 48 volts AC. Surprised it's not higher than that, but whatever. Might be because I need to actually go off of ground on this somewhere over here to check that. I'll flip it over to go to the back side of the board. Super careful here. Alright. So ground plane. This will be the center pin on that bottom rectifier. I think it is. Yep. So it is the 60 volt one that's developing R5. This one's developing 24 volts. We had a rec of that MOSFET on that side too. Probably look at that at with an oscilloscope. I'm going to actually check those voltages on my oscilloscope as well. Okay. Light for this. So, for those of you who are interested in these kinds of things, check the MOSFET first. Yeah, I think that's going to be a pretty typical signal. Almost a square wave that you're going to see coming from a MOSFET, even though that one does have it's not really flat at the peak. I think that's pretty typical. For switch mode power supply, let's change our coupling from AC to DC. Measure voltage measurement, channel 1. On. There we
go. Turn that off real quick. Let's go to ground first. And I'm going to line this up here. Change us from 50 volts to, let's go down to 1 volt. DC coupling back to DC. Turn that back. Let me raise this one up. Put it on here. Yeah. Me touching it with my hand. Let's make it dance. Okay, enough goofing around. Now I'm going to check the rectifiers, which basically Schottky rectifiers are, I guess maybe, if I'm correct in this term, halfway bridge rectifier, because you have two diodes, Schottky diodes. But anyways, okay, let's try this again. There we go. So, as far as that 5 volts is concerned, you might see that. I don't know if that's because of characteristic of the switch mode power supply, but that appears to be a wee bit dirty. Could be that rectifier is starting to go bad. Our means voltage is 5.12 volts. Okay, I'm going to go increase my scale. Let's do 5 volt scale. Let's check that other rectifier. Should be seeing, yeah, I'll have to increase it just bit more. 10 volt scale. There we go. 24.4 volts mean. That one looks a lot prettier. So the question is where do we go from here? Alright, well, you heard me say it. This is unplugged from the wall now. I still need to be careful because I guarantee you those capacitors are still storing a charge. It'll probably take them a while to dissipate that charge if they're not just still holding on to it. So, power supply issues. Common power supply faults I've seen in the past. Rectifiers bad, capacitors, fuses. Hardly ever seen transformer go bad, although they can. To me, I think that, and again, like, and anything I say, I could probably be 100% wrong. So, somebody smarter than me, put some comments down in the doobly-doo.
But the one thing that I'm having difficulty with, so when we apply power to the power supply, when everything was in the monitor, typically you have like a little red LED that illuminates, right, telling you that power is supplied. I do know that the 5 volts come to this board. This board feeds the side panel and the LCD. This board right here, and then that side panel where you have the capacitor buttons, you have leads coming out going to your LEDs. Now overall, the monitor's not going to turn on until you hit the power button, so something is switching or latching saying, hey, power, the capacitor button's been touched. Turn on the monitor, the LED beside the monitor power button turns on. But the fact remains that there is a bottom LED, and I believe that LED is going to be red, and it's not showing anything. So, in my opinion, we have an issue with, even though we got the voltages, we might have leaking capacitors, and these are filter capacitors, so maybe there's some kind of current sense or something. I'm not too sure. And I also suspect that since this board is also driving those lamps, those CCFL fluorescent lamps, I would have thought that the AC voltage we measured over here would have been greater than 48 volts, unless I just wasn't measuring. Well, I was measuring it at the connector. I would have assumed that that voltage would be somewhere around 400 volts AC. But I could be wrong. I mean, I don't know. I have not worked on a computer monitor before. I've not played much with fluorescent tubes, other than I've changed out a ballast once because I just made a guess once at with some overhead lights that the ballast was out bad. That happened to be correct. It was a complete guess. But if there is a problem with this board, I mean, the least we can do for right now, and might have to replace this rectifier down here at the bottom at some point. The least we can do is swap out these capacitors, and then we can plug it back in and see if we have any other, see what indications we get, and then we can play with the monitor from there, troubleshoot more, I guess. So I do have a handful of Rubicon capacitors. These are, see, 25 volt caps. See, 25, 25. I think a couple 10 volt, maybe 35 volt as well. And we'll get them swapped out. For those of y'all interested, kind of mark things out on the board or on an index card, the orientation of these capacitors. You do have a 35, 33 microfarad cap right beside the MOSFET. You have a 25 volt 1000 microfarad cap. That's number 2, so that would be this guy right here. You have a 25 volt 600 microfarad cap. Number 3 will be that one right there. For 25 volt 220 microfarad, it's going to be this guy right here. 5 is 10 volt and 220 microfarad. And there's this guy here that is bulging. And then we have a 10 volt 1000 microfarad cap. Number 6, this guy right here. And like mentioned, I do have some Rubicon capacitors, 35, 25, 10 volt caps.
at these exact specifications. So let's start replacing things. We'll do that with a handy soldering station, and we'll go from there. Now that I have all 6 caps removed, zoom out for a second. I have them lined up in order of 1 through 6, even though I didn't remove them in that order. But anyways, don't know why. Probably need to mention that. But now that I have them removed, I need to fully clean this board with some isopropyl alcohol. I won't clean the board in general, but I need to make sure that I have good clean surfaces for soldering in the new components. For those of y'all wondering what I was spraying on the board, if you call that, it is a QD electronic cleaner made by CRC. I almost swear by this stuff. I'm not sponsored by them. Obviously, I'm a small YouTube channel, but I use this quite a bit. That electronic cleaner is very good. Highly recommend it if you're going to clean PCBs. Made for electronics. It's very quick drying, so I just used it to clean up both sides of the board. And now that I've cleaned this board up, it's going to be time to solder in the new capacitors. Wanted to stop for a second and mention something.
before I solder in this last capacitor. Polarity is very important. So if you see on the side where you have these hash marks and that dot, or over here where this one's marked positive this side and you have a more heavy solid bar on the left, that solid bar will be the negative terminal, just like this dot, and this side is going to be the negative as well. And then you'll line up this negative side of the capacitor through here. Now, I know this section is primarily a lot of fast forwarding, but I double check and I triple check before I solder that capacitor in, because once I plug it in, I really don't want to let the smoke out. I would like for this this power supply board to still be functional. Alright, let this set aside to ensure that it's dry and that the alcohol fully evaporates. But for hoops and laughter, let's test out that bulging cap. This one, yeah, 220 microfarad. Just want to know what it's going to read. And it's obviously way off. I wonder what the other ones are going to give me. So 1,000 microfarad. Might have damaged it taking it out. Be a lot easier if I could have the ability to just clip on some leads. Yeah, that seems to be close. But again, capacitance check. It's not really a full test. You would need an appropriate meter. If I can make a plug, Mr. Carlson's lab on YouTube, he makes some of his own test equipment, and he's got a phenomenal device that runs the gamut as far as checking for leaky capacitors. I've actually been thinking about subscribing to his Patreon so I can make one of those devices that he has myself. Or I could always just go into work and borrow something. But I don't know, y'all tell me. Would it be worthwhile for me to purchase one of his devices? And I wonder if, because I think it's a kind of like a DIY thing. He gives you the plans, you build it yourself. I wonder if it'd be worthwhile for me to build it after purchasing. That was $220. It's coming up as $200. Let's see, $680. You would think that's reading a little high or a little low. It might still be good, but it could be bad. It could still be leaky. This one was another 1,000 microfarad. Oh, get up here. Okay. And hopefully y'all are seeing those readings out to the left there. This one was, what was this one? 33 microfarad. Trying not to touch my fingers. No, skew the reading. Anyway, that was pretty close as well. Well, we can plug back in this power supply and just poke around the board a little bit, see if we still got our voltages. Let's do that next. Okay. 3, 2, 1. On. No smoke. That's at least a good sign. We still have 5 volts. Yeah. 5 volts is still there. For poops and giggles. That's still there. Let me flip this over. Carefully, carefully, carefully. See if I still got my 24 as well. Oh, that should be the DC measurement. Oh, I was checking the 5. My bad. 24. Showing 21. So that has came down some. And I'm wondering if that is a good thing, given the fact that the board does say input 100 to 240 volts AC, 1.6 amps, 50 to 60 hertz, output 5 volts, 2.5 amps, and 19, 1.6 amps. We were at 24 before. So we do have a difference. Let's plug this into the monitor and see what it does. We'll try to mock it up a little bit. See if I kind of quasi reassemble it and see what happens. Alright, so I don't have this fully back together yet. Guess I gotta go back into this, but I do have the somewhat put together cord put into it. And what I'm looking for is this LED here to illuminate once we plug it in, and then see if we can turn it on. So, in which we weren't getting anything before, but let's see what happens. I got to plug this in, and contact. What we got? We got something. The screen did something. What's going on here? Off. Back on. No signal input. It shuts off. Okay, let's put this all the way back together and then we can test out some things to make sure it's operational. Alright folks, there you have it. Speaker's working, monitor's working. Not a bad monitor at all. Let's work through our side panel buttons real quick. Our menu pulls up just fine. Up and down arrows work just fine. Right and left arrows work just fine. And power button works just fine. It's a nice little monitor. Not full 1080p, it's 1680 by 1050. But it is a decent 22-inch monitor. Probably find a use for it for something, either in the office or you know, either that or I might try to sell it. I think they typically go on, I think when I saw comparable monitors on eBay going for about 50 to 80 bucks.
So got some decisions to make. But anyways, I am really happy with this repair. So what do I think was going on? Well, we had a bulging cap, and we might have had some other bad caps, so we replaced all the caps on the regulated DC side of the board, the low voltage side of the board. We saw that the board showed that it was supposed to develop 19 and positive 19 VDC and positive 5 VDC. And our 5 volt rail was good. The 19 was at 24 after replacing the output capacitors. That brought that voltage down to 21. So it could be quite possibly that there is some there's probably a voltage monitor built somewhere into that power supply, so when the voltage exceeds a certain range, it just kills power instead of burning up components, almost like an over voltage lockout. But at least that's my guess. I'm pretty sure somebody in the comments can correct me if I'm wrong or add to the discussion. But anyways, it's a little past 3 o'clock in the morning. I'm super ecstatic, but I'm ready for bed. So without further ado, let's close out this video. Well folks, there you have it. Another successful repair. I will be making some materials available to go along with this video. Visit my website. It's always in the description. I'll take a picture of this and throw it in on the website. Did a little bit research on the rectifiers after the fact to just verify pin out and stuff. Pulled up data sheets. Those will go into a folder as well. And then that IC that I thought was possibly the controlling volume, etc. It ended up actually being that, and I was able to pin out some wires and stuff. But I'll throw in. I don't think that was correct. Again, it's very early in the morning, so I don't think this was pin 3 and pin 2 on here because those are ground. I think we have pins 5 and 7 and 4 and 6 is probably what I should have wrote. But anyways, I'll take a photo of all this. The data sheets are pulled. I'll put it in a folder. It'll be available on the website. But if you enjoyed this video, give it a thumbs up. If you don't mind subscribing, none of that is necessary, but I do appreciate it. And please join in later on for some more repair videos via electronics or mechanics, as well as some STEM videos that I still have planned to do with my kids. But anyways, thank you for your time. Hope you have a good one.